Hey everybody, let's start talking about lesson 7, combination of functions. Two functions can be combined to create a new function. We started to do this a little bit last section. Number one is you can have a combination of a sum, a difference, a product, and a quotient. So we can kind of see sum, difference, product, and quotient. Okay, keep in mind if we use a quotient, whatever the denominator function is means that the denominator function cannot equal to 0 for it to be defined. For the domain, in each case, the domain of the new function consists of all of the numbers that belong to both the domain of the f and the g. The zeros of the denominator are excluded from the domain of the quotient. So let's talk about what this really looks like. So let's say f of x was 5x minus 8, and g of x is 7 minus 2x squared. Let's find f minus g of x. So here's f of x minus g of x. So this is 5x minus 8 minus g of x, which is 7 minus 2x squared. Remember that when we distribute that negative, it goes to both parts. So this is a minus 7 minus a negative is positive 2x squared. And now we're just going to combine like terms. So I end up with negative 7 and negative 8. That's negative 15. And in descending order, we have 5x and 2x squared. So then how do we do f minus g of 4? So remember, in this case, the input was x. But in this case, right here, the input is 4. So what does that mean? So f minus g of 4 means f of 4 minus g of 4. So how do I write that? F of 4 is going to be f of x, but instead of x, we're going to use 4. So we're going to say this is 5 times 4 minus 8 minus, and then g of 4 is going to be this, 7 minus 2 times 4 squared. So if I do this, I know 5 times 4 is 20 minus 8 is 12 minus 4 squared, because of PEMDAS, is 16. Times 2 is negative 32. 7 minus 32, we say is what? Negative, oh gosh, I can't. 25. We know minus a negative is a positive, so we end up with 12 plus 25 is 37. Okay, so this next one, if f of x is x cubed and g of x is root of x plus 1, find the following. So let's find the following so that we can do this. So f plus g would look like x cubed plus g of x, which is root of x plus 1. Okay, and for that, we know that the domain is going to be, well, I know the domain for f of x is all reals, and the domain for g of x means that x has to be negative 1 or bigger. So we know the domain has to include both of them. So that means the domain can only be from negative 1 to infinity. All right, let's look at x, or f minus g. So that's x cubed minus root of x plus 1. Okay, so again, x cubed is infinity to infinity, and minus the root of x plus 1 is still going to be from negative 1 to infinity. F times g of x, so f is x cubed, and g of x is the root of x plus 1. So in order for this to work, it still excludes my domain for x cubed is still infinity, negative infinity to infinity, but this one is still from negative 1 to infinity. So that's the only domain that's going to work for both of them. Then for this last one, f over g says x cubed over root of x plus 1. And so for this one, we have to be a little bit more careful because typically for this, let me show you, for this domain, it was -1 to infinity. But if I plug in -1 here, it's also in the denominator. We can't have it equal to 1. So we actually say this is actually going to be from -1 to infinity, but we can't have it touch -1 because then it would mean that the denominator is 0. All right, let's look at these compositions of functions. So what does this mean? So a composition of the function of f with the function g is defined as, and this is how we read it, f of g of x. We can also rewrite this as f of g of x. Okay, so if you want to write this down, we say that this is f of g of x. Okay, the domain of f of g of x is like the set of all x's in the domain of g, such that g of x is also in the domain of f. So here's what that means. X must be in the domain of g, and g of x must be in the domain of f in order to get from x into f of g of x. So in above, the output of g of x is used as the input of f of x. So let's look to see what that might look like. Okay, so if we're talking about compositions of functions, let's look at this one. F of x is x squared plus 2x minus 1, and g of x is 1 over x minus 2, and h of x is root of 3x. Find a rule for each of the following and state the domain of each. So this one says f of g of x. So remember, f of g of x is like saying f of g of x. So if f is, well, actually we'll write this in pink, f of, and inside of is the g of x. This means every time I see x inside function f, so instead of x squared plus 2x minus 1, I'm going to replace these parentheses, or these x's with parentheses. What's going to go inside of those parentheses? It's going to be g of x. Okay, so we're inputting g of x now instead. So let's go ahead and flesh this out. So x squared plus 2 times x minus 1, but g of x is really 1 over x minus 2. Okay, if I square this, I get 1 over, because 1 squared is just 1, x minus 2 squared, we can leave it just like that, plus 2 times 1 is 2, all over x minus 2 minus 1. We can leave it just like that. And if we're going to talk about the domain, we have to talk about each part. So we know here in this denominator, x cannot equal 2. This, we know x cannot equal 1. So we know from negative infinity up to 2, oops, sorry, I messed up. This is a 2, by the way. I don't know where I got that from. So it's a 2. So, and then we skip 2 because it can't equal 2, and then we start from 2 to infinity. All right, let's talk about g of f of x. Remember, g is in green, so we say g of f of x. So instead of inputting x into g, we're going to input f of x. So g of f of x looks like this. G is 1 over x minus 2, but instead of x, we're going to input f of x, which is x squared plus 2x minus 1. Now let's simplify. 1 over x squared plus 2x minus 1 minus 2 is just x squared plus 2x minus 3. And if I can simplify this by factoring the bottom here, I know negative 3, two numbers that multiply to negative 3 that add to 2 are positive 3 and negative 1. So this is like saying x plus 3 and x minus 1. This helps me just look to see what my domain should be a little bit easier. So for me, the domain cannot be negative 3 and it cannot be positive 1. So I know it goes from negative infinity to negative 3. Starts again from negative 3 to positive 1, and then starts again from 1 to infinity. All right, so let's look at f of h of x. So f of h of x. So let's write this out. So f of x is x squared plus 2 x minus 1. But instead of inputting x, we're inputting h of x. So instead of h of x, it's the root of 3x, root of 3x. Let's simplify it here. Root of 3x quantity squared is just 3x plus, and then 2 times root 3x is just 2 times the root 3 of x minus 1. And then here we're going to look at our domains. Remember here, the domain can be anything. Here, x has to be 0 or a positive number, so that means greater than 0. So that's the only restriction that we have. So we know the domain has to be from when x is 0 to positive infinity. Okay, so for h of f of x, we say h of f of x, which means h is the root of 3 times x, but instead of x, we're using f of x. So this is going to be the root of 3 times x squared plus 2x minus 1. If I simplify this or multiply it out, I get 3x squared plus 6x minus 3. Now keep in mind, basically here, to navigate what's going on with the domain, is I need to make sure that whatever's inside the root is either 0 or greater than 0. So I need to say, okay, if 3x squared plus 6x minus 3 is greater than or equal to 0, let's just find out what that value would be if it's equal to 0, and then test those values and see what's happening. So one of the ways I'm going to do this is I'm going to factor out a 3, and that's going to give me x squared plus 2x minus 1 equals 0. I can divide those 3's out, and I've got x squared plus 2x minus 1 equals 0. So remember, the only way that this is really going to help me is I'm going to manipulate this a little bit so I can use a square root or complete the square to make this work for me, okay? So if I'm completing the square, I'm going to take this 2, cut it in half, and square it. So I'm going to add 1 to both sides. So I'm left with, and I'm going to actually switch where these are in. So x squared plus 2x plus 1 minus 1 equals 1. So if I perfectly factor this, I get x plus 1 squared minus 1 equals 1. Now I'm going to solve, add 1 to both sides, and I get x plus 1 squared equals 2. Take the square root of both sides, plus or minus, and I get x equals, or x plus 1 equals plus or minus the root of 2. Subtract 1 from both sides, and we get x equals negative 1 plus or minus the square root of 2. What happens is when I see those two values, I know it can either go to the right or the left. So it looks something like this when I graph it. So I'm going to say my domain is going to be from negative infinity to negative 1 minus the root of 2, and from negative 1 plus the root of 2 to positive infinity. All right, let's talk about decomposing functions. When you decompose a composite function, you are finding the components of the composition. So it's like going from the result, figuring out how we got back to it. Look for the inner function and the outer function. So here's what this looks like. I notice that h of x is x plus 3 squared. So I kind of see that there's two functions here, a squared and a something squared, right? So in this case, what would you say is the inside function? I'm going to say this right here, this x plus 3 is the inside function, and the outside function is this stuff being squared. So we say the outside function is x squared. Let's look at the inner function here. So I see x minus 5 is kind of like the littler function, and the outside function is 1 over that stuff. So we say 1 over x. The next one, the inside function is x plus 2, and the outside function is the root of all that stuff. So we'll say root of x. And then the inside function, notice how they're the same here. So this is my inner function, x minus 2, And then this squared minus 4 times this plus 5, which tells me that it's got to be x squared minus 4x plus 5. So let h of x equal the root of 3x cubed plus 1, where h has a composition, and write it in two different ways. So what if we said, okay, the inner function was 3x squared plus 1, and the outer function was this root. So we could say, okay, let's let f of x be the outer function, and g of x be the inner function, 3x squared plus 1, okay? And we would say that h of x could be f of g of x, okay? The other way we could write this is let me use a different color. We could say x squared could be the inner function, so we could say inner function g of x could be x squared, and the outer function is the root of 3 times whatever this is plus 1. So we would say f of x could be the root of 3x plus 1. So we would say h of x in this case could be f of g of x as well. All right, let's use the graphs of f and g to evaluate the functions. So remember that this is all graph f, this is all graph g, okay? So let's first rewrite what this really means. So f plus g of 3 tells me I'm taking f of 3 and g of 3. So let's do f of 3 plus g of 3. So let's look at f of 3. You ready? So here's my function f. When I input 3, so we're going to go over when x is 3, we go up and we see that value is 2. And then we're going to add g of 3. So we're going to go over to the graph g of x, go where x is 3, follow it up. We get that value of 1. So 2 plus 1 is 3. Okay, so how about these values? So we're basically using those two functions to find the values. So let's go ahead and write this one out. So we've got f of 1 times g of 1. So let's find those values. F of 1, so we go when x is 1, f is 2, times g of 1, when x is 1, g is 3. So 2 times 3 is 6. So let's look at this one. F over g of 0 is like saying f of 0 over g of 0. And we're going to look for this here. So f of 0, look up here, is 4. And g of 0 is also 4. So 4 over 4 is 1. Let's look at this one. Now this one is g goes first, so g of -1 minus f of -1. So let's find g first. G of -1 is 5 minus f of -1. So we're going to go to f, look where x is -1, follow it up, that's 6. So 5 minus 6 is -1. Let's do f of g of 4. So here's f of 4. Oops, sorry, back up. I'm reading this wrong. F of g of 4 looks like f of g of 4. So first thing we need to know is what is g of 4? So we're going to find function g, go to where x is 4, it's 0. So instead of g of 4, we know that's just 0. So if I'm looking for f of g of 4, I'm saying also, what's f of 0? So go to your f function, find when x is 0, or the input is 0, we get an output of 4. Last one, we've got g, which is in green. So we say g of f of 2. So let's find f of 2 first. F of 2 is 0. So this is now replacing with 0. So what's g of 0? Well, g of 0, if I go over here, at 0, the output is 4. And that's it. So let's talk about some more function operations. So this is our table of values. I want you to get very comfortable with this. We're going to see this a lot with calculus, where we have these inputs of x values, and these are all the outputs for f of x, g of x, and h of x here. So using this table based on what your input is, so for example, if you want to know h of -1, when x is -1, h of -1 is 1.5. Okay, so we're going to use this table to help us find this. Okay, so really quick, I'm just going to color code this if that's helpful to you. Okay, so I'm going to look here, and I've got f, 2 times f of 1 plus 3 times h of 0. So 2 times, let's find f of 1. So here's f of 1 is 4, plus 3 times h of 0, so we're going to find h of 0 is 3. And now we're just going to evaluate. That's 8 plus 9 is 17. Let's look at this one. This next one, h of g of -2 is like saying h of, well, let's find g of -2. So g of -2 is -1. So that's what we're going to input here. And h of -1, if I find that now, is h of -1 is 1.5. And then they're going to say times, so we're going to multiply it by f of, let's find g of 2 first. So g of 2 is -3. And then f of -3, we're going to say f of -3 is -4. And now we just evaluate 1.5 times -4 is -6. Let's look at this one. So here we've got 2 times f of 3. So we know f of 3. We're going to go f of 3 is 8 all over h of -2. So h of -2 is 0.5. We're going to get 16 divided by 0.5. That's like saying 16 divided by 1/2. So if I multiply by the reciprocal, that's 16 times 2 over 1, which is 32. So what about part D? It says, if k of x is absolute value of x minus 3, what values of x is k of x equal to f of g of 0? So first of all, let's find out what is f of g of 0. So f of g of 0 is here at 1, and f of 1 is here at 4. So they want to know, where is k of x equal to 4? Well, I can set this now equal to its function, and I can solve this just like I did in algebra. So I remember, when you see absolute value functions, we do it 2 different ways. We get 3x minus 4 equals 4, and 3x minus 4 will equal -4. Add 4 on both sides. I get 3x equals 8, so I've got x equals 8 over 3 on one side. Add 4 on both sides, I get 3x equals 0, therefore x equals 0 on that side as well. We're almost done. Let's do an application. The volume in cubic meters of a weather balloon is given by V of r, so that's the volume where r is the input, or the radius, 4/3 pi r cubed. If r is the radius increasing at a rate of r of t equals 1/2 t cubed, when t has to be positive in seconds, find the volume of v as a function of time of t. So here's what we've got. We're trying to find v as a function time of t. So let's find v of t. Well, what do we know about t? We know only the radius isn't a function of time. So we're going to find the volume, but instead of t, I'm going to have to, well, what do we know about v? We only have a function for r, right? But look, this is r, and so we're going to put this instead right here. So instead of r, we're going to use r of t. So we know that that's going to be v of, so 4/3 pi r cubed, but instead of r, we're using r of t, which is 1/2 t cubed. Go ahead and evaluate this. We get 4/3 pi t cubed. Cubed is t to the 9th, and 1/2 cubed is 1/8. So this becomes v of t is pi over 6 times t to the 9th. And we're going to go ahead and do our other applications in class. We'll finish this later. That's it for now.